finance and accounting. Today we shall be doing some multiple regression using some financial data. The aim of this channel is to apply econometrics to finance and accounting research. So today we shall be starting with descriptive statistics. I'm using stata 18 edition, and we shall be using some financial data to explain how you run descriptive statistics in stata software. I will load my data, which I already have in my system, and that's the data. Let's have a view at the details of this data. It is the financial data of the consumer goods sector of the Nigerian Stock Exchange. We have the dividend per share. We have the tobinq already calculated. The institutional ownership also calculated. We have the ROA, that's a return on assets, also computed. We have the equity to debt ratio, and we have the firm size that has been computed. These are the variables we shall be using to run the multiple regression. But before we'll do the multiple regression, we'll quickly run the descriptive statistics. To run the descriptive statistics, I'm going to go through the command menu. Sum. I'll pick the variables starting from the tobinq, followed by the independent variable, dividend per share, institutional ownership, ROA, equity debt to debt ratio, and lastly, firm size. That will give us a descriptive statistic of the variables we are using for this analysis. And there, enter. That gives us the descriptive statistics for this analysis. I'm running it using the command menu, that's using the word sum, followed by the first by the outcome variable, which is the tobinq, and next your series of independent variable. Next, we'll also quickly run the correlation matrix. We'll also do the correlation using the command feature. Simply, I can copy the command I used for the descriptive and then change the command line by wiping up the sum and replacing it with SORR. That's the short form for correlation, and press enter. With that, we have the correlation table, and that's it. We are running this with the command feature. Like I said, SORR, tobinq, DPS, institutional ownership, ROA, equity debt ratio, and followed by the firm size. The next is we're going to run an OLS regression using the command feature also. To run an OLS regression, simply type in reg, that's R-E-G, followed by your dependent or outcome variable. In this case, we have the tobinq as our dependent variable. So we have to select tobinq first, followed by the independent variable. I take DPS, that's dividend per share. I take institutional ownership. I take ROA. I take equity debt ratio, and then lastly, I take firm size. So having taken all the variables, the next thing to do is simply to press enter, and your OLS regression will be run. That's it. This is our regression, ordinary least square regression results for the variable tobinq, which is the outcome variable and is depending on dividend per share, institutional ownership, ROA, equity to debt ratio, firm size. And from the regression result, you can see that dividend per share is highly significant, is positive and highly significant. Institutional ownership is also positive and significant. ROA is positive and highly significant. ROA is positive and highly significant. Equity to debt ratio is also, is positive but not significant. Firm size is negative with a coefficient of -1, and it is not statistically significant. So another test that we can always do is we can run a normality test to check for the normality of the data. So one popular normality test that is conducted is the Shapiro Wilk normality test. We can also go through the command menu to run the Shapiro Wilk. Simply typed in SWILK followed by the variables of interest. So we pick all the variables and test for their normality. I'll start with tobinq, DPS, institutional ownership, ROA, equity to debt, and firm size. So, having entered all the variables we want to test for their normality, you enter. So, based on the Shapiro Wilk test, virtually all the variables exhibited non-normality because they are statistically significant, and the interpretation is that they are not normally distributed. Now that OLS regression is built on the assumption, one of the assumptions is that the data are normally distributed. Now that assumption is violated, you might be thinking of running an alternate regression. You might be using bootstrapping or robust OLS to correct for this violation of the assumption of normality. So I'll quickly do. We can also run. Maybe we'll do a bootstrap. I'll use bootstrap method, but at this time I'm going to go through the command. I'm going to go through the menu. I'll go to stata, select a linear model, and select a linear regression. Now, from this window, I select my dependent variable, which is tobinq, and I select all the independent variables. DPS, institutional ownership, ROA, equity to debt, firm size. So I go for the SE/robust and I look for the bootstrap option. We'll bootstrap at 500 and I set it at a random of 1, 2, 3. With Bootstrap, we'll correct or we'll make up for the non-normality of the data sets. So with this now, I can run the regression, a bootstrapped regression. Bootstrapping normally takes some time because it's going through, it's a resampling techniques that is used to normalize the data sets. Now, here is the result of the bootstrapping. And you can actually compare that results with the OLS that was not bootstrapped. From this analysis, you can see that DPS is significant, is positive and significant, and which is the same as the OLS we had initially. The institutional ownership is positive and also significant, which was also positive and significant with the other OLS. And it goes on and on like that. So that is how to run multiple linear regression using stata. The last thing I want to do for this evening is for us to, now that we have run this command, I quickly want to harvest all the commands that we have used, and I'm going to create a do file. I will copy all these commands. That's commands that we have used from 1 to 6 and use it to create a do file. The benefit of a do file is that you can easily rerun your regression without necessarily going through the procedure one by one again. And you can always save it for future work, which you can adapt and use subsequently. It's just a matter of changing the variable names and you'll be done. So we're going to run the run a do file now. I'll go to Window, do file editor, create new do file. Now that I've copied all the commands that we have used, I can paste them here. Okay, so I will need to do some editing. Now, those are the commands that we have used. Let me put some notes. Summary, statistics, notation, correlation, matrix. The next is notation again, OLS regression. Another notation was normality test. That's Shapiro Wilk test. Okay, after that is okay, another notation for bootstrapped Bootstrap Regression. Bootstrap Regression. So this is a do file that I've created for you to see how it's going to run. Let me clear out what we have done, and I will run the commands. Clear. Now I do not have anything on any result on my window. We want to run the do file. Now that I've created the command, all I need to do now is to play the codes, and they will execute one after the other. Here we go. That's it. The results, stata is running the results. The bootstrap is taking a little while, but I'm sure it will be done in no time. So that is how to run a do file command in stata. So far today, we have gone through descriptive statistic, correlation matrix, OLS regression, normality test using Shapiro Wilk, and we did a little of bootstrapping, and lastly was the do file that we created. I hope you enjoyed the session. If you do subscribe to my channel and watch out for next series in this econometrics for finance and accounting. Thank you.